Start recording. Okay, I think we're good. Okay, so looking at this here, first part, you do not need to sketch this diagram for me. But I have this, and we're saying if A is parallel to B, then something is true because of the alternate interior angles theorem. So I just want you to write this piece down for me. If A is parallel to B, then blank, then something, because of the alternate interior angles theorem. Okay, and the reason I'm having you guys do this, or the reason we're going through this, is because if I tell you that lines are parallel, then this opens up all the theorems that we've talked about last class. All these different types of angles that we've talked about are all fair game. If I don't say that they're parallel, then none of them are possible, or I can't use any of them. So this is why it's so important to say if these lines are parallel. Okay, and if this is the case, if I'm looking at the alternate interior angles theorem, what would be true? Well, I can look for alternate interior angles. I can see angles 3 and 6. And remember, the theorem tells us if they're alternate interior angles, then they are congruent. So then I can say, then angle 3 is congruent to angle 6. Okay, and then what else is true? What else can I say? I can also say here that angle 4 is congruent to angle 5. Because those are also alternate interior angles. Okay, so just something to keep in mind on these kinds of problems, or on problems that we've worked on, or proofs that we've worked on. Okay, I can use that theorem to say these angles are congruent. What we're doing now, or what we're doing today, is we're swapping the order. Yesterday, or last class, we said if the lines are parallel, here's what I know about the angles. Now we're going to swap that, and we're going to say, here's what I know about the angles. Tell me that the lines are parallel. And we'll talk about how we do that. Okay, so to do that, we do need a few different postulates and theorems to kind of help us out here. So this first one I want you to write down with me here. It's called the converse of the corresponding angles postulate. So we're writing down a similar postulate to what we wrote down yesterday, but now we're taking the converse of it. And remember, we talked about that last chapter. Converse is when I take the hypothesis and the conclusion and swap them around. Okay, so the converse of corresponding angles postulate says this. It says if a pair of corresponding angles, okay, if a pair of corresponding angles in a diagram are congruent, okay, so when I say in a diagram, I mean the diagrams that we've been working with, two lines cut by a transversal. If a pair of the corresponding angles are what they're supposed to be, which is congruent, then the lines are parallel. Okay, then I can say that the lines are parallel. Okay, there are other things that I could add to this definition to be more specific when we're referring to different parts, but for the sake of just us writing this down, I just want you to have this. So if we can prove that one of the pair of corresponding angles are congruent, then I can say that the lines are parallel. Okay, next one we're going to use here, similar to what we talked about yesterday. Okay, the converse of the alternate interior angles theorem. Okay, I want you to write this one with me as well, and you can abbreviate these as needed. So converse of alternate interior angles theorem. All right, and it says this. It says if a pair of alternate interior angles and we're going to say in a diagram again, in a diagram are congruent. Okay, so same thing. We know alternate interior angles should be congruent. So if we look at one of our diagrams and we see that at least one pair of them are congruent, then I can come to the same conclusion. Then I would be able to prove or show that the lines are parallel. Okay, that is our same conclusion that we're going to be coming to in all of these problems and all of these proofs. Then the lines are parallel. Okay. All right, and then last one here that we'll write fully, and the other two we'll kind of just paraphrase. the converse of same side interior angles theorem. All right, the converse of same side interior angles theorem. Okay, and it says this, similar to what we've said before, we will say if a pair of same side interior angles in a diagram okay, and in this case, we're changing up the first part here. Remember, same side interior angles are not supposed to be congruent there. Remember, same side goes with supplementary. So if a pair of them are supplementary, okay, then same conclusion as always. Then the lines are parallel. Okay, so adding another theorem that we can use to prove the lines are parallel. If we see that there's a pair of same side interior angles and we can show that they're supplementary, then we can say that the lines are parallel. Okay, and then the last two here, you guys can go ahead and abbreviate these. The converse of alternate exterior angles theorem, it's the exact same thing as the interior angles theorem. The only difference is you swap in the word exterior. So what I'm going to say here is I'm going to say similar to, okay, similar to what we'd call, and I'll abbreviate this here, converse of, so I'm going to say CO, converse of alternate interior angles theorem. Okay. So again, something to keep in mind here. It's the exact same theorem, so we can use that. All right, and then last one, converse of same side exterior angles theorem. You can abbreviate that as needed. It's the exact same thing as the theorem we wrote with same side interior. The only difference is I swap in the word exterior. So I'm going to say similar to the converse of same side interior angles theorem. Okay, converse of same side interior angles theorem. Okay, so we have these theorems now, and we can use these to solve different problems, and we can use these to work through different proofs here. So let's practice that a little bit and see what this would look like here. Okay, example 1, we have this diagram here, and we're trying to find x so that the line ML is parallel to PN. So what I'm going to do right now is I'll stop for a sec, or I'll pause. I want you to take a second. I want you to sketch this diagram. Okay, I'll give you guys a couple minutes to do this, but I want you to sketch this diagram here and make sure you label everything. Okay, give you guys about another minute. Make sure you have all this down. And if you're watching this video later, then you can just pause your video, obviously, and then speed up to whenever I start working on the problem. Briley, I'll talk you through that once that gets done, and I'll be posting this video as well. Okay, so if I'm looking at this diagram here, the biggest thing that I want you guys to notice that is different from every other problem that we've done so far is notice I don't have those arrows that tell me that the two lines are parallel. Okay, and every other problem that we've done so far, we always have those little pink arrows or little black arrows that tell us that the lines are parallel. In this case, and the problems that we're going to be working on today, we don't know that the lines are parallel. That's what we're trying to prove. So if this were the case here, if I'm looking at these two angles here, okay, we're trying to show that these lines would be parallel. And if that were the case, what would be true is that these angles would be, notice, alternate interior angles, which means that they should be congruent or equal. So if I wanted to show or find x so that these lines are parallel, I would set these up and set these equal to each other. So I'm going to set 5x plus 7 equal to 7x minus 21. Okay. Like I said, if these lines are parallel, then this should be true, or this is what would need to be true. And now I'm going to solve and figure out what x is. So first thing we can do is we can subtract 5x from both sides. When I do that, these cancel here, leave me with 7. And then equals on the other side, 7x minus 5x is 2x here, minus 21. Okay, continue to solve. We have a negative 21 on that side. We want to get rid of it, so I add 21. So when I do that, they cancel on the right side. On the left side, I have 7 plus 21, which is 28, and then equals 2x. And then last step here, divide by 2. And I get x equals 28 divided by 2, which would equal 14. Okay, so final answer here, would it be x equals 14? And that's what we were trying to find is x, so I don't need to plug it back in. If we were to plug it back in, we could double check, and we would see that these two angles are congruent. And so by the theorem that we wrote down earlier, the converse of the alternate interior angles theorem, if they were congruent, then the lines would be parallel. Okay, so that would be the process that I would go through. Okay, so the setup of these problems is pretty much the exact same. It's just the concept is a little bit different. All right. Other things that we need to look at this with is in proofs, because this can get a little bit more difficult. Okay, so again, I want you to take a sec. I want you to sketch this diagram for me. I'll give you about a minute to do this. I want you to label.
Scroll up to the definitions for a minute.
Yes. Which ones do you need, Wyatt?
Just the last two.
These two here. Okay, I'll save these here. Okay, and like I said, I'm recording right now, or at least I believe I am. And I'll post this video afterwards as well. So if you guys need to go back and look at anything, you can feel free to do that. And these notes will be posted as well. Okay, I'm gonna go ahead and scroll down. All right, so I want you to take a sec, and I want you to sketch this diagram for me. And like I said, if you're watching this video later, you can feel free to just pause your video and then skip ahead to when I start working on the proof here. I'll give you guys about a minute to do this though. Okay, so hopefully you have this drawn down here. Otherwise, you should have time while I'm talking as well. But in this case, we're told we want to use the converse of the corresponding angles postulate to prove the following. And in this case, we're trying to prove the same thing as always. These lines are parallel. Same thing as before. I don't know these lines are parallel because I don't have those little arrows on them that tell me that. So that's what we're going to try to show. So first step here, if I'm working through a proof, we know we want to set up our columns. So statements and reasons. Statements and reasons here. And no matter how complicated the proofs get, we always know the first step. The first reason is always given. Okay, and then the first statement here is angle 1 and angle 2 are supplementary. Just copying down whatever I'm given. Okay, so if we're working through this proof, one piece of good news is that I'm told already the postulate that I'm going to use to prove that these lines are parallel. I'm told I'm going to use the converse of corresponding angles postulate. So if I scroll back up here to our notes, I see that we said the converse of the corresponding angles postulate says if I can show that a pair of the corresponding angles are congruent, or in other words, are the same, are equal to each other, then I can say the lines are parallel. So that's my goal. That's what I'm going to try to show here. Okay, I'm going to try to show that a pair of corresponding angles are congruent. In this case, if I'm looking at this diagram, I only see one pair of corresponding angles. I see angle 1 and angle 3. Okay, these are the only ones that are labeled for me here. So this is my end goal. I'm going to try to show that 1 is equal to 3. And once we hit that, then I can say that the lines are parallel. So that's our end goal. If we're going to work through this, the first question I always want to ask myself on a proof is, what do I know from my given information? Okay, because I don't have a equation to set up. I'm not solving for a measure or for a variable. So what do I know from my given information? In this case, we said the given is that angle 1 and angle 2 are supplementary. So what do I know from that? Well, I know that, or we know that means that they add up to 180. So that's exactly what I'm going to write. I'm going to say measure of angle 1 plus measure of angle 2 equals 180. Again, I'm getting in that habit of asking myself the question, what do I know from my given? All right, and what's my reason for that? How do I know that? Well, if they're supplementary, they add up to 180. That's just the definition of supplementary. Okay, so I'm going to put definition of supplementary angles. Okay, that's just what it means. It means if they're supplementary, then they add up to 180. Okay, so that's the first question I want to get in the habit of asking myself. Once I get a statement from that, the next question I want to get in the habit of asking myself is, what do I know from my diagram? Do I know anything by looking at my diagram here? Okay, well, if I notice here, we know we need to get angle 3 involved somehow. Notice, okay, I see angle 2 and angle 3 are right next to each other on the same line. So remember, this is what we call a linear pair, which means that these are also going to add up to 180. So I'm going to say measure of angle 2 plus measure of angle 3 also equals 180 here. Okay, the two questions I'm getting in the habit of asking myself. What do I know from my given? What do I know from my diagram? Okay, and notice some of you might be tempted to say angle 1 and angle 3 are congruent because they're corresponding. But remember that only works if the lines are parallel, and I don't know that yet. Okay, so what is my reason? How can I say that angle 2 and 3 add up to 180? We have a name for these kinds of angles. This is what we call a linear pair. So my reason would just be the definition of linear pair. Okay, definition of linear pair. Okay, and this is where the problem gets a little bit more complicated, because I've got information from my given, I've got information from my diagram, and now I don't have a clear process of how to go or where to go from here. So I'll just tell you guys, here's where you would want to go next, is notice this whole expression here equals 180, and this whole expression also equals 180. Okay, if two things equal the same number, then they equal each other. And so that's exactly what my next statement is going to be. They both equal 180, so they both equal each other. So measure of angle 1 plus measure of angle 2, that whole expression equals measure of angle 2 plus measure of angle 3. Okay, they both equal 180, so they equal each other. All right, and I would accept a couple different reasons here for the sake of simplicity on this problem. Notice we just kind of took what 180 equaled and we kind of plugged it in for 180. So since I plugged something in, even though it's a whole expression, that's still going to be the same reason that we've used before. I substituted something in. So that is substitution. Okay, and we're getting close to the end here. We're almost done. Remember, I said our end goal was to show that measure of angle 1 equals the measure of angle 3. And we're close. If we look at this equation, we almost have that, except we have the measure of angle 2 on both sides. So if I think of this like an algebra problem, to get rid of it, I would subtract that from both sides. So when I subtract it from the left side, it would cancel out, leaving me with measure of angle 1. And then if I subtracted it from the right side, it would also cancel out, leaving me with just measure of angle 3. Okay, and now we've hit what we were trying to hit. We've shown that angle 1 equals angle 3. And what was my reason for that last step? Well, remember, I subtracted something from both sides of the equation, even though it was a whole angle measure. So since I subtracted something from both sides, that would be the subtraction property of equality. Okay. And like I said, now that I've shown this, this satisfies this postulate that we were told at the beginning. Okay. If I could show that these angles were equal, then I can now say that the lines are parallel. I'm going to say line L is parallel to line M. I've satisfied the criteria for this postulate. Okay, and what's my reason for that? The good news again is it tells us which postulate we were going to use at the end. This is the converse of corresponding angles postulate, or in other words, COCAP. Okay? So something to keep in mind there, or something to look for as you're working through these proofs. The good news is it tells you which theorem or postulate you're going to use. Okay? All right, last one here, and I promise I'll stop talking and you can get to the homework assignment. Example 3 here. Example 3. Okay, same thing as before. I want you to take a sec and I want you to sketch this diagram for me. And I will save you some, well, I won't save you too much time here because you'll see a diagram like this in your homework. So I want you to take a sec. I want you to draw this and label all of the angles. Give you about a minute to do that. And make sure you label all 8 of the angles. Okay, so hopefully we have this written down here. First thing I'm going to do before I start getting into the explanation of this is I'm going to set up my proof because I know I'm trying to prove that these lines are parallel. So statements and reasons. Okay, and notice here we're also given information to help us with this problem. We're told that we're going to use the converse of alternate interior angles theorem. So before I get into this, I'm going to scroll back up and remind myself of that theorem. So the converse of alternate interior angles theorem says if I can prove that, I can show that a pair of the alternate interior angles are congruent, then I can jump to saying that the lines are parallel. So that's what I'm going to try to do. I'm going to try to figure out and show that a pair of alternate interior angles are equal or congruent. Okay, well, good news is I've already given information about angle 3 in my given information. So I see angle 3 here. And then the question would be, what would be the alternate interior angle to that? Well, notice that would be angle 7. So this is my end goal. If I can show that these two angles, 3 and 7, are equal, then I can say that the lines are parallel. Okay, so let's get there. So first step, we know we want to have our given information. Okay, and we're just going to copy down what our given is. Angle 3 is congruent to angle 1. Okay. And if I want to work through this proof, I want to ask myself and get in the habit of asking myself the same 2 questions. First question, do I know anything for my given information? Well, I'm told angle 3 is congruent to angle 1. Okay, that'll help us, but I can't really make another statement off of that. Okay, question number 2, do I know anything by looking at my diagram? Well, looking at this, I have a lot of different pieces of information that I can use here, but one that's going to help me is I know I need to get angle 7 involved in this proof somehow. So the question is, do I know anything about angle 7 and any of the other angles that we've already talked about in the proof? Okay, do I know anything about 7 and 3 or 7 and 1? Okay, well, notice here, if I look at 7 and 1, we see that these are what we call vertical angles. And I know vertical angles are going to be congruent. So I can say angle 1 is going to be congruent to angle 7. Okay, I know that is true. Okay, I don't need to know that the lines are parallel. Okay, because that's what we're trying to prove. Okay, but I can say that they are congruent because they are vertical angles, or what we call the vertical angles theorem. Vertical angles theorem. Okay. And notice I can't say 3 and 7 are congruent because of alternate interior angles, because the lines would have to be parallel in that case. So I'm going to use these statements that I have here. So we've said 3 is congruent to 1 and 1 is congruent to 7. And remember, we have a property that says if A equals B and B equals C, then A equals C. So if 3 is congruent to 1 and 1 is congruent to 7, then 3 is congruent to 7. Okay, that is one of the properties that we talked about last chapter. If A equals B and B equals C, then A equals C here. And what is our name for that? What did we call that? That is what we call the transitive property. Okay, transitive property. I can use that to help me through these proofs. Okay, and notice now we actually hit our goal very quickly. We were trying to show that angle 3 and 1 were congruent or equal. And if we could get to that point, which we just did, then we can immediately jump to saying that the lines are parallel. So I'm actually at my last statement now. I can now say that A is parallel to B. And what is my reason for that? How do I know that? Well, remember, it tells us the theorem that we're going to use at the end here. This is the converse of the alternate interior angles theorem. Converse of alternate interior angles. And that would be the rest of my proof. Okay, so these proofs are, a little bit tougher. And it's a different kind of concept that we've seen before. So if some of this stuff is not making sense, or you're feeling like you're not really following along on how we'd go through these proofs, that's okay. Okay, it takes time and it takes practice to kind of use these theorems here. So feel free to ask questions and let me know as much as you can. Okay, so that is the notes for today. Rest of time, you guys have about 40 minutes to work on the homework assignment. Same thing as before. If you have any questions, feel free to let me know. Okay.